So let's try to understand shifting of origin. So here we have the Cartesian plane, and we are going to consider the two coordinate axes, the x-axis and the y-axis. So here let's name the x-axis as x and the y-axis as y. Now the origin of the two axes are going to be at O with a coordinate 0, 0. Now let's suppose we have a point P, and this point P has the coordinate given by x, y. Now our goal will be to shift the origin from 0, 0 to a new position. Let's say we shift it to O prime, and let's say its coordinate is h, k. Now that would mean, that means the new coordinate system or the new axis is going to be such a way that it is going to be having the origin at O prime. So here we now have a new coordinate system. So we're going to name it as x, O prime, x prime, and y, O prime, y prime. So these are the new coordinate axes. Now our goal will be to find out the position of point P with respect to this new origin O prime. Fine. Now since we have mentioned here that the origin O prime is at the coordinate h, k with respect to O, so that would mean that it is h units from the origin O along the x-axis, and then it's k units along the y-axis. So here we have x, y. So let's say with respect to the new origin O prime, the point P is at a distance of x from the origin O prime along the x-axis, and at a distance of y along the y-axis. Now what's the relation between this x and the x in uppercase? Now clearly we can see here that this distance x will be equals to, so we take h and add it to capital X. This is evident from the diagram. So this entire distance is going to be x plus h. And what about y? Then y is going to be equals to the distance of the origin O prime from the x-axis, so that's k, added to the distance of point P from the new x-axis, so that's going to be y. So that means we have the old coordinate system x represented in terms of the new coordinate system as h plus x and y as k plus y. So this is how we can shift the origin. So this is going to be better understood with the help of an example. Problem number 1. If the axis is shifted to the point 1, -2 without rotation, then how will this equation 2x squared plus y squared minus 4x plus 4y equals to 0 transform? Meaning, so let's say we have the given equation, let's note it down, 2x squared plus y squared minus 4x plus 4y equals to 0. So this is given to us. It would also mean that this equation has been expressed taking the origin to be at 0, 0. So that is that's what's given to us. Now what we have to show here, that this has been transformed to a new location O prime with coordinate 1, -2. So what is going to be the new transform equation? All we have to do is replace the value of x with x plus h. So here h corresponds to 1. So that means we have x plus 1, and we are going to replace the value of y with y plus k. So where k is denoted by -2, that means we have y minus 2. So let's substitute this value here. So our equation is then going to become x plus 1 whole square added to y minus 2 whole square minus 4x. So x is replaced with x plus 1 plus 4y. So y will be replaced with y minus 2, and that's equals to 0. So let's perform the calculation. So we have 2 times x squared plus 2x plus 1 added to y squared minus 4y plus 4. So we're expanding the terms, minus negative 4x minus 4 plus 4y minus 8. That's equals to 0. Fine. Let's further solve this. So we have 2 times x squared plus 4x plus 2 plus y squared minus 4y plus 4 minus 4x minus 4 plus 4y minus 8 equals to 0. Fine. Now let's combine the like terms. So 4x and negative 4x cancels out. Negative 4y, positive 4y cancels out. Now here we have positive 4 and negative 4 cancelling out. Fine. So now we are left with 2x squared plus y squared. Negative 8 plus 2, that's negative 6. So this is simply equals to 6. So that means this is the new transform equation. That means this is the equation of the same point, if we consider a point, but this will be with respect to the new origin, which is 1 comma negative 2. Problem number 2. It's given here that we have a point whose coordinate is 4 comma 5, and it's given here that the coordinate changes to negative 3 comma 9. That means the origin has been shifted. So we have to find out what is the position of the new origin. Problem number 2. It's given here that the coordinate of a point is 4 comma 5. It becomes negative 3 comma 9. That at what point the origin be shifted. Let's try to understand this problem graphically. So let's say we have a coordinate system. We have a point P. So it's given here that it was x comma y. Then this point has changed to a new point, which is x prime comma y prime. The question is, what is the position of the origin? So definitely the position of the origin has been shifted. So this is our new origin. It was earlier O, now it has become O prime. So with respect to the new origin O prime, the point x comma y, its coordinates has changed from 4 comma 5 to negative 3 comma 9. So that is what we need to find out. Okay, let's do that. So that means, let's say originally our point has the coordinate x comma y, which is given by 4 comma 5. The new coordinate point x comma y in uppercase, so that is negative 3 comma 9. So we have to find out the position of the new origin, which is the coordinate h comma k. So we know that we have already defined the relationship between the two coordinate axes. So that's simply x equals to x plus h and y equals to y plus k. All we have to do is substitute the values. So here h will be simply x minus xn, and k will be equals to y minus y. So h will be equals to, so x corresponds to 4. This can be obtained from here. So here x will be 4, y will be 5. Then we have x, the in uppercase, that's going to be negative 3, and y in uppercase, that's going to be 9. Let's substitute the value. So x will be 4 minus x. So x is negative 3. We have 4 minus negative 3. K will correspond to, we have y value, that's 5. 5 minus 9. So h value, so that's going to be equals to 7, and k, that's going to be negative 4. Fine. So that's the value of h and k. So let's write it down. So h and k, we have obtained the value as 7 comma negative 4. So that means the origin has shifted to this new position, which is 7 comma negative 4 from the initial position, which is 0 comma 0. So that is how it is transformed. Let's go to the next problem. So here we have to find a suitable point to shift the origin so that the equation given by y squared plus 4y plus 8x minus 2 equals to 0 no longer includes terms with y or a constant term. Meaning, so here let's start with the given equation. We are provided with y squared plus 4y plus 8x minus 2 equals to 0. So this equation is given to us. Now let's transform this equation. So we're going to make the transformation. We're going to replace the value of x with x in uppercase plus h, and y with y plus k. So let's substitute here. We're going to get y plus k whole squared added to 4 times y plus k plus 8x. So x will be replaced with x plus h minus 2 equals to 0. Now let's expand y plus k whole squared. We'll get y squared plus 2 times y times k plus k squared. Then we have plus 4y plus 4k plus 8x plus h, the 8h minus 2 equals to 0. So we have now y squared. Now we can take y as the common factor and combine 2yk. Then we have 4y. Okay, fine. So we have y multiplied to 2k plus 4. Fine. Then we have 8x, and then the remaining terms, which are going to be plus k squared plus 4k plus 8h minus 2 equals to 0. Fine. So this is a quadratic equation in y. Now here we have to show that the new transform equation does not contain any terms with y and the constant term. So that means it should not contain this particular term y times 2k plus 4, and also it should not contain this constant term. So that means in order for the second term which contains y to go to 0, all we have to do is let 2k plus 4 equals to 0. So solving for k, we get the k value as negative 2. Fine. And it's also we have to make sure that the constant term does not exist. So we will let k squared plus 4k plus 8h minus 2 equals to 0. Since we already have obtained the value of k, the k is negative 2. So we have negative 2 squared, that's going to be positive 4. 4 times negative 2, so that's negative 8 plus 8h minus 2 equals to 0. So here we have 4 minus 10 plus 8h equals to 0. So we have negative 6 plus 8h equals to 0. So h is going to be equals to 6 over 8 or simply 3 over 4. So that's the value of h, which is 3 over 4, and the value of k equals to negative 2, such that this particular the transform equation is going to transform. Okay, so let's write it down. So for the new origin, which is 3 over 4 comma negative 2, the transform equation is going to be, we will get y squared, so the second term does not exist, plus 8x, so this will be equals to 0. Let's move on to the next problem. Problem number 4. So in this problem, we need to find a new origin point such that the equation y squared minus 6y minus 4x plus 13 transforms into y squared plus ax equals to 0. So let us begin. So here we are going to consider that the new origin is going to be at the point h comma k, such that if that's the new origin, that means we have shifted the origin by an amount h and k. So that means x will be replaced with x plus h and y will be replaced with y plus k. So we'll start with our given equation. So we have y squared minus 6y minus 4x plus 13 equals to 0. So let's replace the value of y with y plus k whole square. Minus 6 times y, so y here is y plus k, minus 4 times x, so x value is x plus h, plus 13 equals to 0. Now let's expand y plus k whole square. That's going to give us y squared plus 2 times yk plus k squared. Then we have negative 6 multiplied with y plus k, so we have negative 6y minus negative 6k. Minus 4 times x plus h, so that's 4x minus 4h plus 13 equals to 0. Fine. Now we're going to rewrite this equation. So we have y squared plus, we're going to take y as the common factor. Here we have 2k. Then from negative 6y, we have negative 6 as the common factor. Plus, I'll take negative 4x. And then we're going to combine all the constant terms. So that's going to be k squared minus 6k minus 4h plus 13 equals to 0. Now this is the transform equation. So here we have to show that it transforms to a form y squared plus ax equals to 0. Now in order for it to transform into this form, clearly y squared plus ax, where we see that there is no constant term present here, and also there is no term containing y. So that means this particular term and the constant term that goes to 0. Fine. So let's equate them to 0. So now we are going to equate 2k minus 6 equals to 0. So that gives us the value of k as 3. And then we have the constant term k squared minus 6k minus 4h plus 13 equals to 0. So we have already obtained the value k, that's 3. So we're going to substitute the value k with 3. So we have negative 4 times h plus 13 equals to, we have 9 minus 18 minus 4h plus 13, that's equals to 0. So 4h is going to be equals to 4, which implies that h value comes out to be equals to 1. So this is the value of h as well as k. So that means the new origin. The new shifted origin, we can say, will be at the point having coordinate 1, 3, such that our equation which we started out with, y squared minus 6y minus 4x plus 13, is going to be of the form, we have to show that it was of the form y squared plus ax equals to 0. So here we can also immediately say what's the value of a. So clearly if we compare it, then a value is going to be equals to negative 4. Fine. So we end the session here. This is all about shifting of an origin.